that was... Okay, particular solutions. Because we just did general solutions before lunch. And now we're going to do particular solutions. So, when you have a first derivative, how do you find f of negative 3? Well, what you do is you take your first derivative and integrate both sides. Okay? What's the integral of this?
Negative x to the 5th.
Quick announcement, there will be road construction after school. I believe it's between, I think it's in North Egan and Northwest 9th. So you're going to have to kind of avoid that area. You won't be able to get down that way. So make other plans. Thank you.
Okay. Then what we do is this is f of x and this is x, right? We're going to solve for c. So we're going to put negative 80 equals negative 3 to the 5th plus 3 times 3 to the 3rd plus c. So negative 80 equals, bless you. Okay, negative 3 to the 5th. Negative 3 times negative 3 is 9, times negative 3 is 27, times negative 3 is 81, times negative 3 is 243. Well, the negative's on the outside anyway, so it's going to be negative 243 no matter what. Plus 81 plus c. So, what's negative 243 plus 81? Negative 162, right?
Sure.
Okay, and if we add 162 to each side, we get 82 equals c, right? Yeah. So, f of x equals negative x to the 5th plus 3x to the 3rd. Don't need to know why I put a parenthesis there. 3x to the 3rd plus 82. So then they ask, what is f of negative 3? Well, you stick negative 3 in. So it's the negative of negative 3 to the 5th plus 3 times negative 3 to the 3rd plus 82. Well, negative 3 to the 5th is negative 243 times a negative is a positive 243. 3 to the 3rd is 27 times 3 is negative 81 plus 82. So in the end, we should get 244. Okay? So that's not so bad.
No.
Let's do this one then. Integrate that one. Integral of the first derivative of x equals the integral of 16x to the negative 2nd. Well, this is f of x equals
negative 16x to the negative 1.
Yeah. Okay. Now, f of negative 2 equals 0. So 0 equals negative 16 over negative 2 plus c. So 0 equals 8 plus c. So c equals negative 8. So f of x equals negative 16 over x minus 8. If you put a 4 in there, f of 4 equals negative 16 over 4 minus 8, which equals negative 4 minus 8, which equals negative 12. Okay? Not quite as easy. The integral of f of x equals the integral of 4e to the x. And there's really a dx there on each side. So f of x equals what? 4e to the x plus c. So 16 plus 4e to the 2nd equals 4e to the 2nd plus c. So what's c? 16. Subtract 4e to the 2nd from each side. So f of x equals 4e to the x plus 16. What's f of 0? What's e to the 0? 1. 1 times 4 is 4, plus 16 is 20. Ta-da. Okay. Next. Which differential equation passes through this point? Or which curve solves this different? You know what I mean. All right. So, separation of variables. Y dy equals negative x e to the negative x squared dx. Integrate. So 1/2 y squared equals, oh my, the integral of that. Well, it's e to the negative x squared times the first derivative of that is negative 2x. So we need a 2 here with a 1/2 out front, because then that disappears. Because remember, e to the negative x squared, the first derivative of that would be negative 2x e to the negative x squared. Okay? So if this is u and then du type of thing, no. Yeah, but whatever. So we get that plus c, right?
Okay.
Did you get, because this is this. So if you take the first derivative, you get this. So when we're integrating, we got to go back to there. So we need a negative 2e to the negative x squared to get to there. So then I have to put a negative 2x here
Okay.
with a 1/2 out front. So it's 1/2 e to the negative x squared. Well, it's really easy to get rid of our 1/2s, multiply by 2. So y squared equals e to the negative x squared plus c. Okay, put a 1 in for y, a 0 in for x. So 1 equals e to the 0 plus c, so c equals 1. So y squared equals e to the negative x squared plus 1. Take the square root of each side. Ooh. Dang it. That didn't work, Mr. Bierschbach. I wonder if I had to take the square root first and then solve for c. You wouldn't think I would have to do that. I wonder. Oh, no. Because if we take this to the 1/2 power and we take this to the 1/2 power, it's like this or this, and it's looking more like this one because the e is not negative. I don't know. E to the 0. Oh, come on, Mr. Bierschbach. E to the 0 is 1. So c equals 0. I was going, what am I doing wrong? So yeah, we're good there. Because c equals 0. Woo! Because I thought e to the 0 was 0 for a second and it just canceled out. And that's why I was having a major brain malfunction. Okay, this one. Ew. How do we do this? Well, this is cosine of y, coy. No, it's not coy. It's cosine of y plus 2 dy equals 2x dx. So what's the integral of cosine of y plus 2? Sine of y plus 2y, right? Equals x squared plus c. Then, when y is 1, or when x is 1, y is 0, So the sine of 0 plus 2 times 0 equals 1 squared plus c. Well, the sine of 0 is 0. 2 times 0 is 0. So 0 equals 1 plus c. So c equals -1. So rewriting the equation, sine of y plus 2y equals x squared minus 1. So what is x when y equals pi? So the sine of pi plus 2 pi. Now these are separate. It's not pi plus 2 pi. It's sine of pi plus 2 pi equals x squared minus 1. What's the sine of pi?